Today we're looking at pendulums. Pendulums can come in many different forms. Some examples include swings, grandfather clocks, metronomes, and even pole tennis. The first type of pendulum that we are going to look at is known as a simple pendulum. Simple pendulums are created by attaching a mass to a string or a rod, then applying a force to the mass. Some everyday examples of simple pendulums include a person on a swing, necklaces, and a hanging light. The motion of a simple pendulum can be expressed by a special relationship. That relationship is the mass of a simple pendulum will always accelerate in the opposite direction to its displacement from the equilibrium point. This means that when the mass of the simple pendulum is displaced to the left, it will accelerate to the right, and when the mass of the simple pendulum is displaced to the right, it will accelerate to the left. As a result, the max velocity of the mass will always occur at the equilibrium point, and the minimum velocity of the mass will always occur at the maximum amplitude. In real life, a simple pendulum's amplitude will decrease after each swing due to friction. Friction causes some of the pendulum's energy to be converted into heat and sound energy, which results in the height and amplitude of each pendulum swing to decrease. In order to combat this loss of energy, a driving force can be applied to the pendulum to replace the lost energy. This enables the pendulum to maintain the amplitude of each swing. Another type of pendulum is a physical pendulum. Physical pendulums can be made up of almost any object with some sort of pivot point. One example could be a coffee cup. The coffee cup rotates back and forth around its handle, creating a physical pendulum. Another example is a metronome. Metronomes are commonly used in music to count consistent time intervals by making a ticking sound every time the top of the metronome reaches the center line. You can change the time for a metronome to complete one swing by connecting a mass to the top segment of the metronome. Moving this mass down the rod will result in a faster swing, and moving this mass up the rod will result in a slower swing. Finally, we have spherical pendulums. One example of this is the pole tennis game that I showed earlier. As you can see here, the motion of a spherical pendulum is actually very similar to a simple pendulum's motion. As you decrease the velocity of the mass of a spherical pendulum, the mass will get closer and closer to the ground and to the pole that it rotates around. As this happens, the time taken to make a full rotation increases. We call this time the period. The period of a simple pendulum changes depending on the length of the string or rod that holds the mass. As a result, when many different string lengths are used together, we can create what we call a pendulum wave.